diagram shows a cuboid. AE equals 4 centimetres, so that's this side here. AD equals 5 centimetres, which is this side here, and DC equals 8 centimetres, which is this one here. We want to calculate the length of AG. Now AG is the length from here all the way up to here across this diagonal. Now this is a 3D Pythagoras question. If I draw another line from A to C, which is the diagonal of that bottom face, then I've created two right angle triangles here. The first right angle triangle is this one here from A to C to D. Okay, so I'm going to redraw that triangle down here in kind of 2D form, just so we're looking at it in a much easier way. So this vertex here is the vertex D, this one here is A, and this one here is C. Now in our diagram, AD was 5 centimetres, so this length here is 5, and CD or DC was 8 centimetres, which is this one here. I can now calculate the length of A to C using Pythagoras' theorem. So Pythagoras' theorem states that A squared add B squared equals C squared. Now C is always the side opposite the right angle, and my right angle is just here. And so this side here is the one that I'm going to label as C. A and B do not matter, so I'm just going to go with A as the 5 and B as the 8. Now I'm going to substitute those values into Pythagoras. So I've got 5 squared add 8 squared equals C squared. 5 squared is equal to 25 and 8 squared is 64. So I've got 25 add 64 equals C squared. 25 add 64 is equal to 89, so I get 89 is equal to C squared. To get C on its own, I just need to square root both sides. So I'm going to end up with the square root of 89 is equal to C. So I now know that this diagonal length here is equal to root 89 centimetres. Now, what I actually wanted to find here was the length from A to G. Now we have another right angle triangle here that goes from G to A to C. So this one here is also a right angle triangle. So I'm going to draw this one down here as well. So I've got a diagonal here, I've got a length here, and then I've got a length here. My vertices this time are A, which is this one here, C, which is this one here, and G, which is this one at the top. Now, I've just worked out that the length from A to C is the square root of 89. And I also know that from C to G is 4, because in my diagram, A to E was 4, so this length here is also 4. So I'm going to label that one as 4. And now we just need to use Pythagoras' theorem again. I have a right angle just down here so the angle ACG is a right angle. And so when I label my sides of my triangle for Pythagoras, I'm going to label this one here as A, this one here as B, and this one here as C, because that one is the hypotenuse, and the hypotenuse is always C. Now I'm going to sub these values into Pythagoras' theorem again. So I've got A squared, which is the square root of 89 squared, plus B squared, which is 4 squared, is equal to C squared. Now the square root of 89 squared is just equal to 89. 4 squared is equal to 16, and that is equal to C squared. Now I need to do 89 add my 16, so 89 add 16 gives us 105, so we've got 105 is equal to C squared, and to work out C, I'm just going to square root both sides again. So C is going to be equal to the square root of 105, and that is in centimetres. Now I need to do the square root of 105 on my calculator. So square root of 105. I'm going to change that to decimal by pressing the format, going down to decimal, and that gives me 10.24695077, and so on. My question says to round this to 3 significant figures, so my answer is going to be 10.2 centimetres.